Hey everybody, this is Doug with Artfully Rogue. So not long ago, I made a video called Gasless Flux Core Welding Basics for Beginners. I got a lot of questions from that video. I want to answer those questions here in this video and clarify some information that I provided in the other video. Now, my first question comes from Kevin Kelly 6237, and he asks, when talking about settings on the chart and welding two different thickness of steel, what piece of material do you choose? The general rule of thumb, and this is good for flux core, MIG, and stick welding processes, is that you want to adjust your machine with the thicker material in mind. While these settings are important, it's more about the technique that's going to keep you from blowing through that thinner piece of steel. So for this demonstration, I'm using a 5mm thick flat bar, which is about 3/16. I'm also using a 1mm piece of sheet, and that's about 1/32. Okay, so with that being said, we're going to set this machine to the thicker material. 3/16 means it's going to be about 17.5 to 18.5 on the voltage. Wire speed is going to be about 240 to 260 IPMs. Now that's inches per minute. This machine specifically, because I bought it here in Spain, uses the metric system, which means I need meters per minute. It's about 6 to 7 on this machine. Now on some of your newer machines, including this one, you're going to see a term or feature called synergic. What that means is when you adjust the wire speed, it automatically adjusts the voltage. Now, I won't need to adjust the voltage because that has that feature here. Some of your higher end machines, you'll be able to turn that feature off and separate the two. Adjust your wire speed separately from your voltage. Some of the machines I have in my Arizona shop allow me to do that. It gives you the opportunity to fine tune your settings depending on your welding position, the welding material, and things of that nature. So now let's move on to the technique, and this is the part that's going to help you lay a nice bead and keep you from blowing through that thinner piece. So now, because we're using the flux core process, I removed the gas nozzle since it's not actually needed, and the stick out on your wire is about 1/2 inch to 3/4 of an inch. Now, if the material that you're welding is going to be the same or similar thickness, you can focus your wire right here in the center so that each piece gets equal attention. But now, because we're welding something that's thicker, you want to pull back slightly so most of your attention is here on the thick, and as you start to run your bead, you just want to do quick bumps up, pause, up, pause, up, pause, up, pause. 75% of your heat is focused on the thick steel, with only 25% being brought up there quickly to the thin steel. So let me show you that in action. So as you can see, flux core welding does create a lot of splatter. It's just part of the process. But see if you can catch where I pause on that thicker steel with a quick bump up to the thin piece. So hopefully you were able to see that pause on that thicker steel and then that quick touch to the thin steel. So the pause and then the quick touch, the pause and then the quick touch. And so that's how you actually weld thicker to thinner pieces of steel. Okay, so here's my first point of clarification from the video, the Gasless Flux Core Welding Basics for Beginners. In that video, I mentioned adjusting the voltage and the amperage. Now, the right knob has the A, which you would think is amperage, which indirectly it is. However, when you adjust this knob, you're adjusting the wire speed directly. That's the effect that has when you turn this knob. Wire speed changes. Indirectly, the amperage matches that wire speed. So indirectly, you are changing the amperage, but to clarify, you're moving the wire speed setting, not the amperage setting. And I also want to make another clarification. One of the users said, no, it's not amperage, it's current. Well, technically they're correct. However, current is the flow. It's what's flowing through the machine. You're flowing current through the machine. Amperage is the unit of measure. So we are adjusting the unit of measure, the amperage. We're not adjusting the current. All right, current is what's flowing. Amperage is what you measure current in. So amperage is right, but that user is also correct too. It's current, but you're adjusting amperage. Okay, so the next question comes from Ashon Sote 918, and he asks, something I've seen people do with gasless flux core welding is after going through the first pass, they go ahead and do a second pass. What does the second pass do? It does make it look nicer, but is it necessary? So after your first pass, that would be your root pass. If you need to do a second pass, or commonly known as your fill pass, it would be in situations where you need to fill the joint, or you need an adequate throat size, or you simply need to match the fillet material thickness size. Now, common times when you may need to do filler passes is if you are using 3/16 material or bigger, or if you have maybe a flat or skinny weld joint. Also, if you have gaps between your materials, or maybe they just didn't fit up properly. Now, something to mention here as well is before you make a second pass over your first root pass, make sure that you clean off that slag. If you weld on top of that slag, you're going to just guarantee failure in your material. Now, before I get the questions down in the comments, what exactly is an adequate throat size? Well, take a look at this diagram, and this is a fillet weld using 1/4 inch thick material. The throat of the weld is measured from the corner to the outside of the weld. And a good rule of thumb is to match fillet weld size to the thickness of the material. And this will give you enough of a throat without over welding. Next, Can't Pick No More had a good point. You didn't mention about duty cycle. New welders should know about this as not to damage their equipment. So basically, duty cycle is how long your machine can run before it needs to take a break. Duty cycles are measured in 10-minute increments. So if you see a machine that says 60% at 150 amps, that means it can work for 6 minutes and then needs to rest for 4 if it's at 150 amps. Maybe you see a machine that says 40% at 240 amps. That'd be 4 minutes work, 6 minutes rest at 240. So the higher the amps, the less it can work and the more it might need to rest, unless you get into some of the bigger machines, and then those beasts can just cook. Okay, so maybe now is a good time to mention that if you've got something out of this video, you should check out my School community. School is a platform that allows people to create community amongst like-minded people. So in my case, I'd like to share the knowledge of welding and how to start a business as welding. Maybe you're just starting out. Maybe you're a beginner. Maybe you have a little skill, but you want to take it to that next level. On my School community, you're going to get access to a lot of free plans, a lot of free information, and better yet, you're going to get to talk among other people in the community about the topic of welding and starting a business. Now, I will have some paid courses on there, but they're not there yet. Right now, everything is still free, so come please join my School community, and I'll see you guys in the next video.